solve mean? Let me write a little definition here. So to solve means that given or we know, and this is actually just going to be the opposite. So given or that we know an output for some reason, okay, and we use the function, because functions are important, use the function to determine the input, or inputs if there are multiple ones, okay? So in this sense, when we talk about a function, we're not specifying that it's one-to-one. So a given output could give you, could go back to, or lead you back to finding more than one input, okay? Alright, so to determine the inputs that produce, or lead to, that produce that particular output, okay? So let's do an example of this one. Okay, so same table and everything. Now we're going to do part B, which is solve g of n is equal to 6. So here we have our g of n, which is q. So we're given that g of n is equal to 6, and this is our output. Okay, so we're given a particular output, and we need to go back and try to figure out what does n have to be. So what does n have to be? Or, yeah, what can it be? So what does n have to be to produce an output of 6? Produce an output of 6, okay? And all we have to do for that is look at our table. And so 6 in this case is our output, right? So that's our Q. So we're going to look here. So we see a 6 here, and we see a 6 here. So we just pair those up and look back to see what our n was to produce that 6. And n was a 2 in this case and a 4 here. So here's an example of where we get two different inputs could lead to the same output, which is fine because that follows the rules of being a function. This isn't one-to-one, okay? But it is a function nonetheless, alrighty? So in this case, our answers would be n equals 2 and n equals 4. So at this point, you might be thinking, so what exactly is a function? So what is a function? We know in general terms, or in like physical terms, in applications for the real life and everything, is that, or the real world that is, a function can represent, okay, the relationship between two quantities. But honestly, like, what is a function? Are we going to actually use numbers, or are we just going to use tables all day? And the answer would be no. Because when possible, what we do is we represent functions with particular formulas, okay? So when possible, we can define a function by expressing some kind of relationship between two quantities, by expressing the output, okay, that means our dependent variable, as a formula, some kind of formulaic thing, right? So as a formula involving the input quantity, okay? And I'll show you guys an example of this, the input quantity. Okay, so here's an example. So, i.e., let's say our h of a, remember our height depending on age, that's our function. We never defined it explicitly, but it could be something like this, is equal to 1/2 the age minus 40, which is probably not accurate. I'm just saying this is an example of what you could see as a formula, as a given formula for a function, to define a function, right? So this means that our height, when you plug in a certain age, so this is our age, right? So when you plug in a certain age, this is our age again, because we see that same a, right? That's the same variable here. Then all you have to do is divide by 2 and subtract 40 from it to get what the height should be in, I don't know, inches or meters or whatever. Okay? So anyway, so this is just an example of an explicit formula, okay? So let's do an example that we could see involving formula representing a function. So let's say we get something like the following. So we have like 2n plus 6p is equal to 12, okay? So now what we're going to do is write p as a function of n, okay? So what we want is p is equal to some function of n, alrighty? So in this sense, if we look at it this way, if we want this equation here, and to somehow transform it into some equation like this, where our p is represented as a function of n, that means we have to get p by itself, right? And usually the dependent variable is written on the left side, so that means we want to get p by itself on the left side, okay? So let's work with it a little bit. Let's do some algebra here. So all we have to do, let's start again. So 2n plus 6p is equal to 12, okay? What we want to do is isolate this p, okay? So what we're going to do first is just subtract this 2n to the right side. Okay, so that goes away. We just get 6p is equal to 12 minus 2n. If we divide by 6 on both sides, divide by 6, we get p is equal to 12 minus 2n over 6. And if we just split that up using the denominator, we have 12 over 6 minus 2n over 6, which goes to 2, right, because that simplifies to 2. And then we have minus n over 3, okay? So this thing here, see where I'll just rewrite it up here. So we've reached the point where we're at p is equal to 2 minus n over 3, okay? So see how here this follows the formula for like function notation and everything? So p is now in terms of, it's represented as a function of n. And this here is our explicit formula for that function. Okay? So this would be our answer by writing p as a function of n. Okay? Alrighty, one last note is just that at the end of this section, there's a list of, or like a chart kind of thing, of what are called toolkit functions. Okay? Toolkit, or basic toolkit functions or something like that, I believe the book calls them. So basic toolkit functions. So they're, like I said, they're at the end of the section, and there you can take a preview of what we'll learn later in some future sections and future chapters and everything like that. Okay, where you'll see stuff like parabolas, like U's. You'll see things like kind of like S shapes, they're called. Okay, you'll see some other like funny things like that. That's actually a square root. And yeah, so you can preview those and kind of get a jump start, like I said, on what we'll learn in the future. Okay? So that's it for this concepts video on functions and function notation. I hope that helps, and I'll talk to you in the practice problems video if you watch.